Part C. What score will place a child in the top 25% of the population? Okay? Now, the WISC score follow normal distribution. Top 25%, it should be what? The upper tail. Okay? 25%. Now, if I tell you this is 25%, what can you say about the other side? Because normal curve are density curve. If this side is 25%, the other side must be what? 75%. So what can you say about this point? By definition, this is Q3. Remember, 75% of observation less equal to Q3. And the upper 25% of observation greater equal to Q3. So we try to locate Q3, okay? And how can we find Q3? Again, we need to standardize what? We need to standardize X. X, subtract the mean, which is 100, divided by standard deviation is 15. And convert X score to Z score, okay? And this one convert to what? To standard normal. So this one convert to Q3 minus 100 divided by 15. Okay? Q3 minus 100 divided by 15. Now, how can I find Q3 minus 100 divided by 15? Now, this is the way how you're going to find it. Go to the standard normal table and you move your finger down. But this one is the one we told before. It doesn't work for this question in the sense that in the previous question, we give what is Q3 and we want to find corresponding shady area. But now the whole process has been reversed. I give you what? The size of a shady area and I want to find the corresponding what? Interval. So instead of beginning with Z-score, we should begin with probability. And what is our clue? The clue is this. The size of this area is what? 0.7500. However, in the table, you don't find exactly 0.7500. Okay? What you find in the table is the closest number to 0.7500 is 0.7486 and 0.7517. And 0.7486 corresponding to a Z-score 0.61, 0.67. And 0.7517 corresponding to Z-score is 0.68. Okay, let me rewrite this one in our transparency here. Okay? We actually don't find exactly 0.7500. What we found is 0.7486. And the other one we find is 0.7517. Okay? And this is corresponding to 0.6 row. Okay? And if you move your finger up, you find this is what? 0.07. And this one corresponding to 0.08. Okay? So, we want to estimate what's the corresponding number here. Okay? As we can see, 0.7500 is actually almost in the middle of 0.7486 and 0.7517. So we're going to estimate this one by what? We're going to estimate this one by what? The middle of the two, right? The middle of the two. So the corresponding Z-score, okay? 0.7486. The return z-score is 0.67. And 0.7517, the returning z-score is 0.68. So we want to estimate (0.7500), and this can be estimated by the average of these two z-score. 0.67 plus 0.68 divided by 2, and this number is 0.675. Okay, so we put this one, Q3 minus 100 divided by 15 is roughly equal to 0.675. And we have one equation with one unknown. We can solve for Q3. So Q3 is roughly equal to 100 plus 15 times 0.675. And this number is roughly equal to 110.125. Okay? Now, let's continue to part D. Okay? Let's continue to part D. What is the median and IQR of the score distribution? Okay? Let's look at the normal curve. Now, we know the mean is what? Mu. And this is given. Mu equal to what? Mu equal to 100. But we also know mean equal to median. Why mean equal to median? Because symmetric property. So median is also equal to what? 100. But we know median is also what? Called Q2. Okay? So we have solved the first question. What is the median of the score distribution? The answer is median is what? Median is also equal to 100. And remember, it's also equal to Q2. Okay? Now, second one, we want to find IQR of the score distribution. So, what is IQR? IQR is Q3 minus Q1. Okay? And in the picture above, we know what's Q3. Q3 is 110.125. And we don't know Q1. That means we need to repeat the step in part C. Do we need to repeat the step in part C to find Q1? The answer is no. If you do that, you just waste your time. Okay? To find Q1, we can use symmetric property. We don't need to repeat the procedure in part C. Okay? And how this can be done? Let's look at the picture here. If this is X, and I know Q2 is median, is 100, okay? Is equal to mean. And I know Q3 is 110.125. And I want to figure out what's Q1, okay? How can I do this? Well, to find the length from here to here, we can apply Q3 minus Q1 is Q3 minus Q2 plus Q2 minus what? Q1. Minus Q2 plus Q1. After cancellation, you still get what? Q3 minus Q1. But this one I can write a little bit differently. I can write Q3 minus Q2 and then plus Q2 minus Q1. And what's so special about this expression? If you look at our picture here, Q3 minus Q2 is this. Q2 minus Q1 is this. Because symmetric property, they are actually the same. So here, I don't need to find Q1. All I need to do, since they are of the same length, okay, they are of the same length. All I need to do is I write 2 times what? Q3 minus Q2. And I know Q3 is 110.125 and Q2 is 100. So the resulting answer is what? 20.25. That is IQR. We can use what? The symmetric property. Let's see, let me move on, okay? So I don't need to what? Q3 minus Q2 plus Q2 minus Q1. Since these two segments are of the same length, so I just find out Q3 minus Q2 and double the length of the segment, okay? And Q3 we know is 110.125 and Q2 is 100, which is mean is equal to median, right? This is something we found already. So if you find the answer, 2 times the difference of the two numbers, it should be what? 20.25. And this is IQR. Okay?